Today we're going to be talking about elements, but mostly about compounds and mixtures. So we've already talked about elements, looking at the periodic table. All of these things here that you see here on this periodic table, these are elements. Hydrogen is an element. Sodium is an element. Gold is an element. So elements, they're also called substances, have the same properties throughout. They're just matter that have the same property throughout. Oxygen gas. It's all oxygen atoms in there. All right, so this is just saying the same thing, but I gave you some pictures. Here's mercury. These have mercury atoms all throughout. Gold bars have gold atoms all throughout. And here's a little model here. This shows two elements of the same elements. They're stuck together, but that's okay. They're the same element. So we still consider it an element. Here are elements, the same type of elements. They're not stuck together. We still call them elements. Moving on to the new things. We have a compound. So a compound is when you have two or more elements that combine to form something new. So it's a chemical reaction. They combine and they form something completely different. So you take the element of sodium and you take the element of chlorine and you combine them and you get table salt. All right? You take two hydrogen atoms and two oxygen atoms and you put them together, you combine them, you bond them, and you get hydrogen peroxide. So a compound is when you take two or more elements and you combine them or they bond to form something new. So in the models here, I see this element. It's represented by the black circle. I see this element with the white circle, and I see that they're stuck together. They're bonded together. So they're not separate elements. It's one brand new thing. So this is called a compound. This over here, same thing. I've got elements here. I've got a different element here, but it's stuck together. It's bonded together. That is a compound. So here I have an element. I have the oxygen element. Now, if I take two more elements, or one more element really, and I bond it to the oxygen, it is no longer an element. Now this is a compound. And it's the compound water. But also, when I make a compound, I don't call them atoms anymore. I don't call them by their individual names. I call it a molecule. So this is a water molecule. And you also see it represented like this. So this is just a chart that shows some common elements and compounds. So I have hydrogen element, oxygen element. You see it's the same. Nitrogen element, it's the same. Chlorine, the same. It doesn't matter if it's one chlorine atom or 500 or 5,000 chlorine atoms. It's still going to be an element because it's the same thing. But the second I take two or more elements and I combine them, I get something different. Nitrogen oxide, water, nitrogen dioxide, carbon dioxide. Those are compounds. And these are called, they're not called atoms anymore. We call them molecules. All right. So now we're going to talk about mixtures. Mixtures are when two or more elements come together, but they do not form anything new. So this is more of a physical change. Nothing new is formed. So if I took a cup of water and I put some rocks in there and I mixed it up, I have a mixture of rocks and water, but it didn't form anything new. It's still, when I look in there, I'm still going to see rocks and water. That's a mixture, right? If I take some colored sand like over here and some iron filings and I mix them up, I can mix them up so the sand and the iron filings are mixed together, but I'm not going to form anything new. So it's not a compound, it's a mixture. Peas and carrots, same thing. Shampoo, same thing. If I look at my diagram here, or my model, I see an element here and an element here, but none of them are bonded together. That's my clue. Two different elements, but they're not bonded. That means it's a mixture. But over here, I see elements that are bonded. I see this one here, that's a compound. And I see this here, it's the same thing, so that's an element. I have a compound, I have an element. These two are not bonded. All of these are not bonded. That means I have some type of mixture. Now there are two different types of mixtures. Heterogeneous mixture and a homogeneous mixture. Hetero means different. So heterogeneous mixtures are mixtures that are not the same throughout. They have parts that are different from each other that you can actually see. You know, look at these M&Ms. I can see all the different colors, right? I can mix up the M&Ms as much as I want, but I can see the green ones from the red ones, from the blue ones, from the yellow ones. Same thing with this fruit salad. I can see the watermelon, I can see the pineapple, I can see the grapes, and this oil and water. These are mixtures, but they're not compounds. These are mixtures, and they're not the same throughout. They don't look the same throughout. So these are heterogeneous mixtures. No matter how much I toss that fruit salad, that watermelon and those pineapples are never going to look just like the grape. They look different. I can see it. So this is a heterogeneous mixture. Now, when I can't see it, we call it a homogeneous mixture. So homo means the same. A homogeneous mixture is a mixture that looks the same throughout and you can't see the different parts, like chocolate milk or orange juice. Orange juice has sugar in it, preservatives in it, but all you can see is the orangey color of the orange juice, right? Ketchup is a great example. Ketchup's got sugar, salt, vinegar, tomatoes, maybe some other spices in it. But all I see is this red viscous liquid. I know there's different parts in there and you can pull those parts out, but I can't see them. It looks the same. So that is a homogeneous mixture. It's all about what I see. This is my little science joke that I would have done in class had we not been distance learning. So this is my distance learning joke to you. Hope you figure it out. See you.